All right, guys, let's get started. Well, it's great to see so many of you being interested in akka-HTTP. Hadn't expected that. I've got a lot of content, and there is not so much introductory material onto Akka or Spray. So if you are not too familiar with that, there are links at the end that you can use where you find other talks from previous conferences and other material so that you can get the background there if you still need it. I'll focus on the HTTP side here. So when TypeSafe announced last year that Spray will become part of Akka, we got some questions like this. Why does Akka need HTTP? Does that really fit, right? There was a question like, isn't it feature creep? Is it too high level? HTTP and Akka, right? If Akka is actors, how does HTTP come into play there? And that's a good question, and it makes sense to go back and look at what Akka really is to understand how HTTP fits into the picture. So when you go to akka.io and you read up on what Akka calls itself, then it calls itself a toolkit and runtime for building highly concurrent, distributed, and fault-tolerant, event-driven applications on the JVM. That's a long thing. You can also look at the promise that's a bit more catchy, and it says, Akka wants to make it easy for everyone to build concurrent and distributed applications. That's the point, right? And there are two things in here. One is concurrent, which is traditionally hard. If you look at introductory Akka material, you'll see tons of examples on why without Akka, it can be really hard to program concurrently and really make use of the modern hardware that we have now and that we'll have in 10 years. And there's another important thing there that's distributed, right? Akka wants to make it easy to build distributed applications. And that's even harder with the tools that we usually had 10 years ago, 5 years ago, and so on. And when we think about distribution, then there's one very important theme there, and that's integration, right? Distribution means integration. You need to integrate different parts, different subsystems, if you want to build a distributed application. So between your own subsystems, Akka gives you stuff to make it easy, right? You can use Akka remoting and the new Akka cluster modules to help you just, work with your own subsystems that you control. But all your applications, or most of your applications, will not live on an island, right? They will just be part of the big data soup that we have out there. So you need to integrate with other external systems. And that's what akka-HTTP is, right? If you want to talk to other systems that you may not have under control, then akka-HTTP will help you, hopefully, because HTTP is the most successful integration protocol to date. It might not be perfect, but it is the most successful. Any library, any language, any platform, anything will be able to talk HTTP more or less. So being able to give your application an HTTP-based API is crucial, and that's why akka-HTTP comes into play to make it easy for you. Okay, so as most of you know, who has worked with Akka before? Everyone, yeah. Who's worked with Spray before? Also, a lot, that's great. So you know that akka-HTTP is based on Spray. So just let's take a short look onto Spray. What is Spray? It's an embeddable HTTP stack that is built completely in Scala, not wrapping any Java libraries. And the focus is integration layers. Now, there's integration again. It's about the layer of your application that you use for integrating with other things. So it's not necessarily for web applications. That's what Play is for, room 4, I think. And it's server and client side, right? Because you want to consume as well as offer services. So that's also something that tells it apart from server-centric web application frameworks. And Spray is fully integrated into the TypeSafe stack, so it's easy to use the same kind of thread pool configurations. Just the general configuration of your application is the same as for everything else in Akka. You can use the same debugging tools and so on. It makes it easy. So the core features, just one chart on what feature Spray delivers, and one core is an immutable case-class case-class-based HTTP model. Right? That's a lot of things. If you've worked with Spray, you know that we have tons of classes that just model everything that you need when you work with HTTP, like media types and content types and char sets and encodings and all those things. It comes with a small layer, low-level HTTP client and server layer that you obviously need. And it has higher-level constructs on the client as well as on the server side where you can build, we can easily define your API behavior using a DSL. And it is fully asynchronous, non-blocking, actor-friendly, testable, all the nice things that you need. And it's because it's Scala and actors all the way through, rather than at some way in your stack bridging onto something like Netty, which is implemented in a completely different way. It makes it easy to tune and debug your application once you're in production. And akka-HTTP is something like Spray++. So it's not a completely new thing that we built on the green field. We take Spray and we go through everything and apply polishing, apply the latest thinking, what we have learned, all those things. We take the chance right now to do breaking changes because this is the time, if they're required. One major point, the second point, Java APIs. As long as we were in Spray, we had the luxury of just being completely in Scala. We didn't have to think about Java at all. This now changes. So a big thing that we're working on is giving everything in Spray a Java API. And you can probably see that it's not always easy with just thinking about the identifiers. In Spray, we have the application JSON media type, for example. It's just called application/JSON in backticks. How do you translate that into Java? So that's the things that we work through. We simplified the module structure somewhat, but there's one core improvement that stands out from everything else. Yeah, there's one really important thing, and that's that akka-HTTP is now completely based on reactive streams. Now, and I want to stress that. So reactive streams, right, are the important thing here. So I thought about how I might, just make that clear that that's the key thing. So, right, yeah, you get the point. So because it's so important, I want to take a small detour and look into reactive streams, maybe from a little bit from a different side than what you might have seen before when Roland and Victor introduced you to reactive streams in the first place. Because there were some things that we learned from Spray that gave us, a lot of appreciation for what reactive streams bring to the table. One thing that we had several times is actually this scenario, where a client comes to us, or a user comes and says, oh, we use Spray to build some really shiny new service. It's great, it does everything we need, but we still have this legacy backend that needs to sit around somewhere. It runs some old servlet container, and certain things, for certain requests, we are just proxying the requests over to the legacy backend, right? And this is usually the setup. You have a wide area network, so the internet that the client comes across to your new backend, and then on the same LAN you have the legacy backend. So, and then you have this situation: a request comes in, we proxy the request, it goes back to the legacy backend, and the legacy backend delivers an 8 GB response across the LAN, and we proxy that to our client who happens to sit in New Zealand on a really, really slow connection. Now, you can see where the problem is when you write this, yeah? Because it's right there. You get squeezed. Because this thing is probably fast and delivers 8 gigabytes like this, but Spray sits there and says, okay, great, but I need to somehow funnel this over to New Zealand, right? So please, don't flood me with your data. So what we need is pushback there. And that's harder than necessary right now. If you want to build this with Spray, it's a bit difficult, right? The way we do it in Spray is that you can say, when we read the things from the legacy backend, when you read the response coming in, you can tell the network, suspend reading. I've had enough, please, just don't read from the socket anymore. That's a command that you need to send. But the problem is, you have this guy dumping 8 gigabytes onto you, or 30 gigabytes, right? And your command might not actually make it through in time to actually have an effect before the whole application just explodes because you have an out-of-memory problem. So that's clearly not good. There, we need something better. So when we think about this in a bit more general terms, then this always applies when you have this asynchronous processing pipeline. Like, for example, an HTTP request to response pipeline that you might build in your application, right? So there's a request coming in, you have a couple of steps, maybe implemented as actors, hopefully, probably. So every step does something and then dumps its result onto the next guy and so on. And in the end, you have a response that goes out to the client, all nice and shiny. But what happens if one step is slow, like this one? Then we need, just like before, we need pushback up the chain, right? We need to stop those guys or slow them down that are ahead of us. And this, the important thing to realize is it doesn't help if you just apply pushback at one boundary. You need to apply it, there and there and there and so on. So it's contagious. It goes on and goes on and goes on because you're just moving the problem away, but it stays there. So you need to move it all the way to the client to really solve it. If you just push it out a few steps, then you've just moved it maybe out of your responsibility zone and the team next door has to do it. That might work partially in big corporations. Anyway, this is the core problem that we're solving, or that we're trying to solve. And as Roland has shown before, those things in between are those asynchronous boundaries, and they are the ones that are being solved by reactive streams, that's the focus. And as you've seen before, it's basically the same idea. The question is, how do I transfer data from across an asynchronous boundary from a producer to a consumer? How do I do it? What kind of modes do I have? Those things are asynchronous. They run in their own time, in their own threads, in their own processes, whatever. So, and there are two standard ways. One is pull, right? I can just go in, ask, and if there are no data there, I'll just block. And then eventually it comes back with data. That's cool, it's pull. This is easy to understand, but as you know, blocking has serious scalability issues because you're just wasting the thread that you're sitting on. No one else can use it. Not good. This works best when the producer is faster. So if the data are already there when I'm asking, then I don't need to block, or not really block long. And then it's good. But if the consumer is faster than the producer, then you'll block, and then you have the problems. So this is good, but only when the producer is faster. So if you do it in a different way, if you say push, that's how you usually do it with actors, right? The naive way with actors is you just push. If you have something, you just fire and forget to the next actor, and you're done. This is straightforward, easy to understand. Performance isn't bad as long as the consumer is faster than the producer. If the consumer is fast enough to handle the data, then that's perfect. And that's how many applications out there work, right? They work happily in production, everything's good, and that's the mode that they use. But it's based on hope. It's based on the hope that you always have enough resources on the consumer side to actually, deal with the load. And the effect is that once you monitor your servers in operation, you kind of look at the resource utilization and you see, okay, 10% is all good, all shiny, but once you get to 50%, 60% CPU load, you might kind of feel a bit strange. You're like, oh man, I know, if there are certain things that might break if CPU load goes to 90%. And then that's not good. So you solve the problem by adding more hardware, get CPU load down, and then everything is good again. You see how this works, but you won't deal with the occasional thread on Hacker News about your nice startup. So this is how you do it right. You signal demand from the consumer to the producer, and you say, okay, I'm ready to take on 5 more, or 10 more, or 100 more, or 1 more. That's what I want. And then the producer delivers those elements when they become available asynchronously, but never more than we're asked. That's the key point. And this has a number of benefits. It's this dynamic push-pull mode that Victor said before. So it automatically, this strategy automatically adapts to whoever is faster. If the producer is faster, then, and the consumer asked, it will immediately get the elements, right? So it's more or less the same as pull. If the consumer is faster, it'll just signal demand and then sit there and wait, give up its thread, and when the data are available, it will receive it. So then you have the same performance as push. So this mode kind of combines the benefits of push and pull into one, automatically, and that's nice. And what is important is that we can now run in bounded memory, more or less, if we know this will never explode because we will never have to have unbounded buffering, and you can actually increase machine utilization. Once your whole application is built on this system, it's not a problem. If you're, as Roland has shown before, you can run it 100%, but you won't blow up because there's no hope involved, and that's the key. Okay, so let's look again at our pipeline processing scenario. Basically, you signal demand in this direction, and then the elements flow in this direction. That's how it works, and that's how it needs to work. You can think about this if you go across several machines, right? You can build pipelines that go from one machine via TCP into another machine, all the way through the machine, out and again, up until you get to the other side. And because TCP implements flow control, you can put reactive streams, if you think about them as pipelines, right onto TCP, and TCP will connect those pipelines in a proper way. So you can do this, and that's cool. You need to make sure that all the pipelines, all the elements are properly connected together, right? Then everything will be fine. If you open it up somewhere and you allow for, the back pressure channel not to be carried over properly, then it's like you rip up a hose and it'll just, blow up in your face. But this is possible, and that's cool, and that's also possible with akka-HTTP. So you can think about this. This might be an HTTP client, and you might have the intermediate nodes, might be proxies, built on reactive streams, and then this will all go through, and you have an HTTP server there, and the data will go like this, and it'll all be nice and shiny, and you'll never have this 8 GB problem that we saw in the beginning. So that's the niceness of reactive streams and how they are really important to make Spray and HTTP on Akka nice and tight. So that's basically reactive streams all the way. Then it's like tight seals, right? There's no way to come out. So one chart, reactive streams. What are they? If you haven't seen the talk before, it's basically, I call it pipeline processing done right. The focus is on defining how you get data across this asynchronous boundary. And the reactive streams project is actually not more than an API that defines this, and there are different implementations, like akka stream is one implementation, and there are probably other implementations. We'll see a lot of them in the future from all kinds of people, and they most of the time provide DSLs like RxJava, for example, for stream transformations. They have lots of use cases, so it's not anywhere HTTP-centric. You can use it for anything that works in this kind of data streaming scenario. For chopping up work, it's good for scaling things because you can just define small steps and just connect them to each other in a pipeline scenario. And it's a joint effort, as Victor has nicely shown before. So how does it fit into akka-HTTP? So when you think about Spray or akka-HTTP, you see that there are all kinds of applications for streams, right? Requests on one connection. A stream, there's a stream of requests, especially if you enable pipelining, right? Because then there might be from one request, you might have a whole flow of requests coming in. And in the same way, there's another stream going out from the server with responses going out to the client, and that's also a stream. It's another stream. Then if you think about chunked messages in HTTP, so messages that have transfer encoding chunked, then they as well are a stream. There's a stream of chunks, maybe a stream of video or something that is being streamed. And even if you don't have a chunked message, you still might want to treat the bytes of the message, no matter whether it's a request or a response, as a stream of bytes. Because if it's a large something that you don't want to hold in memory at once, then it's good to think about it as a stream. So you want to deal with it as a stream. So, and these are all the cases where we move from the old model that we have in Spray into or onto a stream-based model in akka-HTTP. So let's look at the interfaces. Well, like, what does it look like? This is important because the yellow stuff is what you are going to implement. And the stuff in the middle is what akka-HTTP gives you. Let's look at the client. From the client side, it's relatively easy. You have two things, right? You have something that you dump requests in, like a pipeline end. You stuff requests in it. And on the other side, you have another hose, another pipeline, where responses come out. And this forms something that does something across the network, but is something that you can just plug into your own pipelines. So you write a certain stream transformation in your application, and you take something that akka-HTTP gives you and plug it in the middle, and that turns requests into responses. Very simple. On the server side, it's the same thing, just the other way around, where you provide in your application the connector that turns requests that come in into responses that go out. And I've drawn it like this because you're obviously, like before, you need to make sure that the pipeline is closed, right? You cannot rip it out. You could just terminate the stream there, take out the requests, and then generate responses and dump it into the other thing. But then you'll lose the back pressure connection. Because this way, if you do it this way, then you have effects like, for example, if responses go out slowly, so the response channel is slow, and you close the loop like this in the end, then this will work and actually slow down the client in sending requests in the first place, right? So the back pressure carries on from this response channel all the way through here up to here. So because you might not be able to send responses, this guy might not be able to send requests. And this only works if this is closed, right? So that's important. Always think about your stream applications as a pipeline setup, that you make sure that everything is nicely connected. So finally, we get into code. So what does it look like in Scala? This is the API that akka-HTTP gives you on the server side. It's basically two things. If you bind a port, you get back a server binding that has a local address, and then it has a stream of connections. And that's already a stream, right? It's a pipeline, and things come out. And you can decide at your own speed what do you want to, take out of that pipeline. And this pipeline gives you incoming connections, because that's what a server ultimately does. It produces connections, server-side HTTP connections. And each connection has a remote address, wherever the client sits, and then it has exactly those two fittings that we've just seen, right? It has a producer of requests and a consumer of responses. And your job is to provide the thing in the middle. So let's see what this would look like if you actually, if you write it. This is a simple HTTP server that is just doing a ping pong thing. In the beginning, it might seem a bit intimidating, so let's see. So there's still IO-HTTP, which you might know from Spray. It's just an akka extension. You send it a command. You ask with a bind command. You say, okay, I want to bind to localhost port 8080. It gives you a future because eventually you're going to see a binding coming in. So, and when the binding comes in, this thing runs. And what we're doing here, you might recognize this from Roland's talk before. We're basically using the akka stream DSL for transforming the stream of connections that the binding gives us. And here we just say, for every connection that comes in, let's do this. This one. So we say, okay, if the connection comes in, the connection has a request producer and it has a response consumer. So, and what we're doing is we're just mapping. Simple. We simply map requests onto responses in the middle, and then we produce to this other guy. That's it. So you don't see the back pressure, right? It's nothing that you have to worry about. You just think about how you want to transform the data side of the connection. And the akka stream infrastructure underneath takes care of, making sure that the back pressure is handled correctly and so on. So that's nice. So it doesn't make it complicated for you. It's not hard to do it. But you need to stay within the reactive streams world. And then this works. Quite easy. If we move to the client, it's a bit different but similar. So in the client, you don't bind, so you don't have anything that gives you connections. You just get a connection directly. You can ask the HTTP layer for a connection by sending it a connect command, for example. And then you get back an outgoing connection, and that consists of a remote address and a local address, and then something called a processor, which is essentially nothing else than one object that implements a producer as well as a consumer at the same time. Because you can just take that, as we've seen before here, and stuff it into your own pipeline. So if you think about this as a pipeline, then this is the thing that you put in the middle. And there's one interesting thing here, which is it gives you the ability to put in a custom context object that is here the data type T. So you don't just put in a request and then at the end you get some response out, because if this was the case, then you would have to make sure that in your own code you associate the responses that come out with the requests that have gone in, which if you use pipelining, for example, there might be 10 requests going out and then there are 10 responses coming in. So you need to make sure which one was which, right? So usually you would have to use a queue or whatever to kind of associate the two. If we give you the chance to just attach to a request your custom object, like whatever it is you choose, you'll get it back with the response. So that makes things much easier on your side, and you can just associate them nicely. That's why there is a T in here. So, more code. What does the requests and the responses and so on look like? So you might recognize this. This is a request. It's basically the same as the one that we have in Spray. So it's just a case class. It's fully immutable, and it has a method, a URI, headers, entity, and a protocol. And all those are properly typed. If you work with Spray, you know that. So the method is not a string, and the URI is not a string. It's a proper type. It's registered. You get all the nice type safety from the compiler that you are used to. There's one interesting thing that you might want to remember for 2 charts down, and that's the entity is a regular entity, whatever that means. We'll see in a second. The response, the same, it's just an entity, and it has a status code, which is properly typed, and then a sequence of headers and the protocol and so on. So this is the same as in Spray. You'll recognize it. It feels identical. So the interesting bit is the HTTP entity. So because this is where the streams come into the messages that we've talked about before, right? So this is an abstract data type. So there are 4 different entities in akka-HTTP. The simple one is strict. A strict entity is one that has a content type and it has a byte string. So you have the data already, right? So for example, if you want to create a small hello world response, then it's easy because you already have the string, right? There's no point in putting it into a complicated structure. You can just use it directly. So it's a strict entity. Has the nice benefit that it's also comparable. So if you have 2 requests that both have strict entities, you can do value comparison on them because the data are already there. But that's not the general entity that you'll see in a message. Generally, the normal one is this one, right? So you have a content type, a content length that you usually get in your content length header, and then you have a producer of byte strings. So this is a stream in a request which you get as another stream of requests. So there's no problem in nesting streams in structures, as you can see here. And the benefit that you have from this is, it's quite important, it's also something that was not that easy in Spray, is sometimes you want to get the request right away as soon as the initial part of the request has been parsed and before the entity has been read, right? So maybe if someone posts a gigabyte in file, then it makes sense to look at the headers right away as soon as they become available to check, is the user actually authorized to send me 1 gigabyte? And you can, if you don't ever attach to this data stream and actually pull the data out, they won't be read from the network. They'll just stay where they are. But you can already look at the rest of the request. And then you can decide, well, you know what, I'm only going to read the first byte and then throw the rest away if I want to, or you can dump it into a file, you can do whatever you want. It gives you more control over when data are read from the network and so on. And it's the same abstraction that you use on the outside for the requests. So there's no difference, right? That's the prettiness. If you have chunked responses or chunked requests, then the entity will look like this. You have a content type. You have no content length because chunked requests and responses cannot have a content length. Instead, they have another type of stream, which is a stream of chunked stream part, which I'm not showing here. It's simple. It's just a chunk and a last chunk, because the last chunk in your chunked message cannot contain any data. It can just contain a trailer or some extensions and so on. There are some funky things in HTTP that you can attach to those chunks. But it's similar to the default case, only that you don't get byte strings, but you get something else that can contain extensions and so on. And this is the interesting bit that is that actually, here, down this one is different for requests and responses, because HTTP has, if you know that, in HTTP 1.0, you had the chance of terminating responses just by terminating the connection. So you could leave away the content length header and just say, okay, here's a response, and it goes on and it goes on, and you terminate the connection to signal that the response has ended. So this, we call this close delimited. And you can only use that for responses. That's clear, right? Because if you did it for requests, you would terminate the connection at the end of your request, which kind of defeats the purpose because you want to read the response. So, and this is now properly typed. So there's a proper type that does it in a way that is very similar to this one. So this is much nicer than what we had in Spray. In Spray, we have byte strings. So all the entities are byte strings. Or you can have a stream of chunks, right? So if you wanted to do something like see the headers early, you would have to tell Spray, well, simulate chunks. And you could say, okay, you want incoming auto-chunking, right? That's what we had. And so the need was already there, but the abstractions weren't there to work with this properly. So this is much nicer. And it actually reduces code a lot on our side implementing this. So it's not just for you that it's better, it's for us as well. So let's look at the module structure. In Spray, we have, I don't know, 7, 8, 10 modules, a lot. And maybe we've gone a bit overboard there over time. So in akka-HTTP, we'll reduce it down to 2 modules. There's going to be the akka-HTTP-core module, which contains what we had so far in Spray HTTP. So it's the immutable model, all the case classes. And then we have the low-level components that used to be called SprayCan. So this is the core component that everything sits on, right? And then there's another module, there's going to be another module called akka-HTTP. That's the proper thing that depends on akka-HTTP-core, and it comes with everything else that you know from Spray: unmarshalling, decompression, encoding, support for JSON, for various JSON solutions. It'll come with the routing DSLs, because there will be more than one. So far we just have one for Scala, but we'll need one for Java as well, which will look different. And the test kit and so on. So this will all be part of the akka-HTTP module. And for now, we are dropping support for Spray Servlet. So if you didn't use that so far, Servlet is a way that you can use the high-level components of Spray on the server side inside of a servlet container. And we had that was actually the oldest module because that's what we started out with. But after we had introduced SprayCan with the custom server, almost everyone used the custom server, and we had very few users actually using the servlet stuff, so we just cut it for now. So what's the roadmap? Where are we going? Actually, we wanted to have out the pre-release of akka-http-core out today. It's all done. We finished it yesterday. It all got merged yesterday. But it got stuck. It got stuck in the release train. The release train got stuck. There's some issue that we couldn't resolve from here. So it'll be out very, very soon because there's no more code changes required. It's just about publishing it. So it'll be the end of this week or maybe next week that you'll get your hands on the core module, the first bits of the core module, which contains the server that I've just shown, as well as the ability to use clients for individual HTTP connections. There are small things missing, like the connection pooling things on the client side. That will come very soon, and then we'll have the complete akka-http-core module done on the latest Reactive Streams API, because that's still also unstable. That's something that we've been fighting with in the last months, because so much input needs to be integrated into the Reactive Streams API, and there's lots of discussions, as you can imagine, between all those great engineers that are coming together for Reactive Streams, that things have drawn out a bit. But we're shortly before a new release of the API, which then gives us a new release of Akka Stream, and then we can do akka-http-core and give it to you so you can use it. So after that is done, we'll add the akka-http module. Finally, then we'll add WebSockets. Who wants to use WebSockets with Spray? Yeah, yeah, this is the most popular ticket that we have. It's one of the oldest, and there are like 150 plus ones on it. It'll come, but so far it was just too hard to build it and then carry it over across all those different refactorings that we had to do so far. And then after all that is done, obviously the end goal, or one of the goals, is to move Play onto akka-http. So that Play can use or make use of this nice Scala-only and Akka stack underneath. And that will probably happen incrementally, and how exactly that's all going to work and so on, we'll work out later. But that's the basic idea. So there are resources. If you want more information, come check out akka.io, Spray.io. There are more talks about Akka and I.O. You can ask on the various mailing lists. We'll merge eventually, of course, the mailing lists. So there will only be Akka user, and Spray user will just be folded into that. But we're not there yet, so if you have Spray-specific questions, of course, we're still there, trying to help you as much as we can. And that's it. Questions? We still have 5 minutes. Yes?
Does this going away of the servlet mean that it's hard to run it in Tomcat?
The question is whether it's hard to run it in Tomcat, and whether that's the reason why the servlet goes away. It's true. Actually, the servlet API doesn't give us everything that we need, or that we would need to implement that properly. Just because traditionally it isn't really asynchronous. Asynchronicity was kind of plugged in version 3, but it's kind of hard. It's very buggy in many ways, and you can't rely on the fact that if it works on Jetty, that it will also work in the same way on Tomcat or on Glassfish and so on. So we would have to really, expand our test base to make sure that it works properly and so on. So there are lots of complexities, and that's the reason why we currently took it out. One question, Heiko.
What will happen to the support for Spray.json?
Yes, Spray.json. That's another thing. Yeah, the JSON things that we have in Spray are quite old, because Spray.json got started, I don't know, 3 years ago. Back when we started Spray, there was nothing really that we could use that was type class based and simple and so on. That's why we started with Spray.json, which is not part of the main Spray repository, as you may know. It's a side project, and there's nothing in Spray that completely depends on Spray.json. You can also use Play.json or Lift.json or JSON4S or any other JSON model if you wanted to. But still, of course, we realized that JSON is very important. Most APIs somehow want to pull in JSON. So there's currently an effort to unify play JSON, spray JSON, JSON4S, all those things. We're currently in the process to work with TypeSafe and the JSON4S folks to come up with a common AST for that, so that there's one data model for JSON that you can use and that's interoperable between different libraries. That's an ongoing process. We had several discussions on this in the last weeks, but we're in the middle of getting that done. So before too long, you should get some announcement on where the whole thing is going. Yeah. But we have no dependency from akka-HTTP on this, so it's a side thing. Next question. Yes? Okay. So the question is about what about SSL, TLS support, and so on. So obviously, encryption is important, and it needs to be built in right very far down in this layer. So it actually, in Spray we implemented it in Spray because there was nothing underneath, but it should actually be part of akka-IO, right? akka-IO sits underneath akka-HTTP because the stack is in a way where you have the JDK offering the Neo APIs, and then on top you have akka-IO, which translates everything either into an actor-based message model for working with TCP or UDP. And after streams have been added, there is a new kind of API on akka-IO, which gives you, on a TCP level, the stream-based API for byte strings, right? So unparsed, just raw bytes. And on this level, we will have to implement SSL and TLS. So that for you, as a user, there's no difference. So you just say, I need streams for TCP, and you just flip a switch and you say, I want them encrypted or I don't want them encrypted. And there is we will give you the chance, better than it is solved now in Spray, to determine yourself when you want to renegotiate things, properly set certificates, and all those kind of things. This will all also be polished over what we currently have in Spray. But this is not yet available. So currently there's no SSL, TLS support for akka-IO. But this will come, and since it's important, it will probably not take long before we have that. Yes?
Yeah, question about the roadmap. So what's your estimation for the release of the HTTP module?
So the second module, the big one. So the goal is, of course, to get it done as soon as possible. We were very confident that we can get akka-HTTP-core out way before Scala days. We were like, Scala days. When is that? In June? Easy, right? And now here we are. So you know how it is with deadlines. So I'm not going to say any dates. Yeah, it's lots of people are waiting for it. TypeSafe, Play, we have lots of people, right? There's no reason to delay anything. It just takes as long as it takes, and we are trying to focus and cut features like Spray Servlet, for example, where we need to in order to enable more progress. But so far we have dependencies on streams and the APIs and the Twitter and Netflix guys to decide on whether the method should be called on next or request more or whatever, right? So, yeah. So, ASAP. Next question. Yes?
What support is being built in for speedy and potentially HTTP 2.0 features?
Yeah, so HTTP 2.0, we just had the new RFCs come out for HTTP 1.1, so that's, and we're almost fully compatible with those, so that's good. HTTP 2.0 adds new things that are certainly interesting. They will come after akka-HTTP has been implemented, so we won't delay the second module because of these kind of things. So we'll see whenever we are there what is the current state of HTTP 2.0. You know, what are people using? What is really implemented in the browsers? And things are very vibrant there, so things change a lot. So we'll decide when we're there, what exactly gets implemented. Yes, more questions.
There are 3 layers of abstraction in Spray line.
Yeah, so the question is, when you look at the client side in Spray, then you have in SprayCan 3 different API levels when you're on the client side. You can decide to manage HTTP connections yourself. You can open one connection and just manage it yourself, decide when you send requests, parse responses, and so on. Or you can go one level up. You can say, okay, please open a connection pool to one host, like, I don't know, I want to talk to Google, open at most 10 connections to Google, and then let's use this pool for this stream of requests that I have for you. So that's what you can currently do. And there's a third API where you can just say, I have a request here, please give me a response for that, and do it in any way you please. And this will stay exactly like that for akka-HTTP. So we'll have the exact same APIs. So you'll have the connection-based, the host-based, and the request-based API. What is currently implemented, so the pre-release that is done, implements only the connection one, like the very low-level one, because the connection pooling comes on top, but there's not a lot missing, so we'll have that very soon. One more question? Yeah. A very good question. When you start a project now, what would I recommend? Rather start with Spray or start with this shiny new thing right away? I would recommend that you start with Spray right now, just because this is all too rough and too unstable for the moment. So you'll probably have certain things. It depends on, you know, how risk averse or so on you are, and it also depends on whether you really need those features, right? If you have large requests and large responses, or you are in one of those scenarios where you proxy to something fast, then this might make sense, because it's painful in Spray. But if Spray already gives you everything that you can use right now, you have better documentation, it's stable, it's proven, I would go with that, because we will give you a proper migration guide. So once we are ready, you will have something that takes you by the hand, more or less, and tells you exactly how to migrate. And you'll definitely recognize most things, right? If you stay at the high level, then you probably won't see too much of those changes underneath. It'll all be automatically good. That's the idea. There will be some changes, of course, because, as I said before, we take the chance of introducing or doing breaking changes now, because that's the time where we can do it. But as long as you stay on the high levels, it shouldn't be too hard. Okay, I'm around for the whole conference, so if you have more questions, find me in the hallways. I'm going to be there till tomorrow. So thank you very much again.